Flying car industry turns to solid-state batteries for commercial takeoff. Solid-state batteries could become essential for delivering the safety, performance, and energy density needed for large-scale deployment of flying cars. As the flying car industry moves from prototype development toward commercial deployment, attention is increasingly shifting to the technologies needed to support safe and scalable operations. Su Chingpeng, founder and CEO of GAC Govi, a low-altitude mobility company incubated by GAC, recently described solid-state batteries as the essential path for the future of flying cars, highlighting their potential to deliver the energy density and safety required for aerial mobility. At the same time, investor expectations are evolving. Rather than focusing primarily on technical specifications and performance claims, capital markets are placing greater emphasis on practical indicators of commercial success, including vehicle deliveries, profitability, production readiness, and the timeline for obtaining airworthiness certification. Flying cars follow a path similar to early EVs. Su compared the current stage of the flying car industry to the position electric vehicles occupied roughly a decade ago, when the market was still transitioning from early adoption to large-scale growth. He argued that aviation mobility could advance even more rapidly than the EV sector once adoption reaches a critical threshold. According to his outlook, the industry is expected to establish a sustainable commercial ecosystem by 2030, supported by technological progress, regulatory approvals, and the gradual rollout of low-altitude transportation services, Car News China reported. After entering the market with its first production model, GAC Govi has been advancing toward regulatory approval and commercial deployment. Its flagship aircraft, the Govi AirCab, opened for pre-orders in 2025 and officially entered production in May 2026. The Chinese company aims to complete airworthiness testing and secure type certification (TC) by the end of 2026, while production certification (PC) is targeted for the first half of 2027, paving the way for larger-scale manufacturing and commercial operations. Safer, longer-range flying cars depend on solid-state batteries. In the long run, battery technology is emerging as one of the most important factors shaping the future of aerial mobility. Su noted that solid-state batteries will play a central role in enabling the next generation of flying cars by delivering both the energy density required for longer flight ranges and the safety standards needed for commercial operations. Furthermore, the business case for solid-state batteries is markedly different in aviation than in the automotive sector. Whereas car makers are pursuing the technology largely to lower costs and improve competitiveness in high-volume markets, flying car manufacturers can absorb significantly higher battery costs due to the economics of aircraft production. Su noted that conventional aircraft are far more expensive to build than automobiles, giving eVTOL developers greater flexibility to adopt advanced battery technologies. As a result, solid-state batteries can already be deployed in limited production runs for aerial vehicles. Over time, broader adoption across the automotive industry is expected to drive down battery costs, making flying cars more economical to operate and opening the door to wider commercial use. However, Su also warned that flying car production is likely to scale more slowly than traditional automobiles. Extensive design iterations, airworthiness certification, and manufacturing validation requirements make the path to mass production longer and more complex, resulting in a gradual ramp-up in deliveries.